Hey, hey, hey! We're back. Welcome to Code Gets Creative. I'm Andrew. This is a channel where we do all sorts of creative coding. And today is part 3 of a project called Light Blocks, where we're controlling Philips Hue lights with Blockly. Let's really quick kind of recap what we can do so far with our program. And then I've got kind of a to-do list of things that we can try today. So should be cool. Let's dive into it. Here is the UI for our program. We got a block here. Last time we introduced this run button, and the back end actually executes some of this stuff now. So we can say turn the light on, wait for a little bit, and then turn the light off. And you can see right behind me, on top of this keyboard, there's this little light that we can watch. So click run. Light turns on, waits for a bit, turns off. Sweet. So that's what we have so far. Also, last time we tweaked some of the design of these blocks, like the shape of these blocks. And so notice how now we have this concept of set color to something. And color is actually a data type that exists in our app. And so we've got this color picker that's going to make it really easy to choose something simple. But then we can also start to do really powerful stuff where you can build up a color from its components, right? You can chuck in some numbers here, and it'll turn all of that into something that's on the color palette. So that's awesome. The only problem with all this is that it doesn't actually work yet. The UI shows up, but if I were to try to run this right now, our server would crash because we don't actually know how to evaluate these blocks. So that's what today is all about. Let's dive over to a quick to-do list. You can see some front-end code over here and then some notes over here. Step 1, I actually want to change out the renderer for these blocks. This looks cool, but it's a little bit old school, a little bit 2000 and late. There's a new renderer that looks more like MIT Scratch, so we can switch to that. And then we're going to evaluate expressions, and we'll dig into that. So let's see. Here's my editor, and I should be able to go into the workspace configuration right here. And if I remember, it's just renderer. And it's called the Zelos renderer. If I save that and refresh, you'll notice that things look quite a bit different. More kind of flat UI, bigger text, which I like. That doesn't show up quite as nice anymore. You'll notice it's oh, I see. Interesting. So I guess the whole thing shows up as that color, and then you have to just click right there. Okay, so we may want to tweak that a little bit. Other than that, though, I think everything looks great. You see how the shapes here kind of help you understand what plugs into it. Yeah, so I'm a big fan of this renderer. So there you go. And we are off to a very strong start. We can already check off that very easy to do that I've been thinking about doing. So let's talk about evaluating expressions. What do we mean by that? Well, what we currently have is the concept of executing statements. And any block that's shaped like this, where it's flat on this end, and it's not round on the edges, but it has this this puzzle connection on the top and on the bottom. This is a statement. It plugs in right here. We know how to run those. We know how to execute those. Problem comes as soon as we have shapes that go inside of that, right? So set color to something. We need to actually fill in the blank, and we need to run whatever's inside of that as code. And then the result of that needs to get passed back to this bigger block right here. So that's what we got to do. there are a few different ones that we need to do. Yeah, notice we can't drop that there. We're gonna have to redesign this weight block first. I think that's the first thing we should do. So we're gonna make it so instead of having just a text field where you type it in, it'll be this like empty slot where you can drop in another block. We'll default a block to like exist in there. But then you can either do like just a numeric literal, just a number that never changes, or it could be like the result of another expression, like choose a random number. And that's the next thing that I think we'll want to do in order to kind of prove that we can do more like dynamic things with it. Yeah, so that's these first two. And then we start to get into like kind of more complicated, set a color from components. It basically means like this guy needs to work. And we're set up pretty nice to do that because we did make this block work. Like this is able to execute. So as soon as we can get this evaluating from sub expressions, and then we'll basically be able to reuse a lot of that logic in this guy, and it'll plug right into that. It'll be sweet. Okay, let's do it. So, weight with numbers. Here is my front end definitions for blocks. And I'm actually going to be brave, and instead of pulling up the Blockly dev tools, I'm just going to make changes to the code itself. So that's right here. We add a dummy input to our block, wait for time seconds. So you'll notice that for some of these other ones, you say, where is it? Set color, yeah. So set color, yeah, set color to a color, and this is just like a blank spot. So let's grab this. This is going to be called time. And then we remove that. But we do need a check. What was it called again? Add check? I've already forgotten. Come on, regex, tell me. Set check. Okay, sweet. So we can have some type safety. I think the types are all capitalized in Blockly. Okay, so if we refresh this bad boy, oh, the text has all disappeared. Yeah, okay, that makes sense. So let's bring this stuff back, and we need to say wait for time, and then we say number of seconds. Format that a bit. Yeah, there we go. Okay, things are making sense now. So we changed the UI of our block. Now we need it to actually like do a thing. So let's go to the back end now. We've got all of our server stuff. It's this wait block right here. This is what gets evaluated. And let's just do this for now. This is basically what it used to be, or what it used to default to. But we'll be able to see this happen. So if I rerun my server, there we go. Then I can come over to here. Let's actually make an interesting program. And let's like set this to like something else that when we switch to it, it'll be obvious that we're actually evaluating it. But if I click run, it turns on, and it does wait. It doesn't wait the right amount, but then it turns off. And so over here, so we ticked right here for this wait block. Okay. And now we could do something like, let's just like log out this block. And this will probably be a big mess, but we'll be able to see like the whole DOM underneath it, or all the XML underneath it. So click run, it's running. And there we go. So we've got this big nasty thing. Cool. This is too big to like unpack all by itself. So maybe what we do instead, let's see. Yeah, you can see here's like the raw XML that we sent as text. So we've got a block. Let's see, what does this match with? This one. So we say wait, and then there's a value name equals time, and then we've got another block inside of it. So what we need to do is we need to say grab a value block, or grab a value node in this XML where the name equals time, and then evaluate that thing, and then whatever the result of that is going to get executed. Now, let's see, here's set color simple. I'm gonna pull these up side by side. You'll notice that we've got this like get field value. So I think what we basically need to do is like get the, what is it? For time? Yeah. Get the block for the time value, and then evaluate that block. As time seconds, and then pause for that many seconds. Yeah. Sweet. Okay, so we've got this like get field value. I think we could do something kind of similar. Here, we'll be lazy and just like copy paste for now. It's basically get value. I mean, I want it to return a block essentially. So let's return element. Maybe we call it like get nested value. Maybe we want to find the field node. We actually want to find the value node. And the tag name is value. The name is the field name. Value name equals that. So let's actually call this value name. Rename some things. And now, what are we doing here? First child. Okay, so we don't need to do this. This is all like just taking text inside of a block. We actually just want to return value node. Now let's see. Value node is actually of type child node. We happen to know that we can cast here though. Okay. Yeah, see, we're doing a cast right here as well. Oh, now hold on. We actually... So this is going to give us this. We don't want this though, we want this. So we need like const child block Or maybe like nested block. And this, yeah, I think we basically want to say like value node dot first child. And then if that doesn't exist, oh, okay. Now this is kind of interesting because like if there's no nested block, and we can here, we'll try it right now. Boom. Oh boy. Wait. Look at that. So actually, if you don't fill in the blank there, it just doesn't exist. So I think in order to protect ourselves, we need to say you may or may not get an element. So if there's no value node, we're going to return null. But let's say that there is a value node. You get the nested block. This should be unreachable. Like this case should be impossible because if you've got a value, you'll get a child block. So maybe we say something like, but no nested block. Yeah, so I think that's still an error. And then we return the value node. No, then we return the nested block. Yes, that's right. All right, this is a child node, and we cast it to element. Nice. Okay, so now we should be able to pull that out. Get the time block. Yeah, we can say like time expression. We'll pass in the block, and then we need to pass in time. Cool. So let's see what we get there. And let's see. Okay, let's we're not gonna have a raw time anymore. That won't exist. Get rid of that. Yeah, there. Okay. Our fake comments line up, or our fake code lines up with our comments now. Here we go. Chuck this in here again. Run. We got our child block. And I don't know, it's kind of just a big mess. We should reuse this like printing function. Stringify a block. That's what we want. Let's and then we stringify our time expression block. What? Oh yeah, okay, that only exists if it's an element. Fine. Oops. Okay. Yeah, let's give that a try. And we hit run. Oh! Element is not a block. Yikes. Why is it not a block? I guess we can find out, yeah? Look at that. Block name is not block. Shouldn't it be block though? I mean, we should have gotten this. I wonder if value node.firstChild actually doesn't work because it's giving us like a text node. It's basically giving us like, you know, the white space between here and here, which we don't care about. So in that case, we basically want to do this. I'm going to say nested block is value node.child nodes. And I think that's it, actually. Let's give that a try. Okay, server's running, hit run. Hey! The time expression block is math number. Perfect. Okay, nice. So, yeah, I feel good about that. We can carry to that for now. So now we have this time expression like syntax tree that we have to evaluate. So we need to have some kind of a function that's like evaluate. Oh, and you'll notice that like wait block already has this evaluate. So really we need to say like, you know, somehow we'll get the handler and then we'll be like handler.evaluate something like that. The thing is, it's a little bit weird to like reference handlers directly. So I kind of think what we should do instead is we're passing in an environment. Maybe we say that the environment actually evaluates it. Or what we could actually do is like, instead of passing in the environment, we pass in the interpreter, and then we say interpreter.evaluate, which I think probably makes more sense. Yeah. Okay, so we're gonna make some changes. Here we go. Actually, let's time seconds equals, and it'll be like interpreter dot evaluate time expression, and then interpreter is going to be able to figure out, oh, we're passing in a block of type math number, so here's how you interpret it. So we're going to say interpreter, get that to yes, that exists now. Problem is we're breaking the rule here. So let's say this passes in interpreter. So we change this from import, and now we have broken everything. We will bring that back just for a second. No pun intended, I guess. So let's see. We're actually just going to pass in this. Change all this stuff. Ah. So notice how this used to be the environment. So now we just have reference to the interpreter. I think we need to say, you know, we're gonna have to do a little bit of indirection. And that's okay, because we need all this other like interpreter level stuff. We come back over here. I'm gonna put here get environment. And that is going to return this dot environment. Yeah. So now that's happy. Oh, looking clever. Multi-line interpreter dot get environment paren dot light on. Except I misspelled interpreter. Okay, so that looks good. Light off. Close that. Start block. Yeah, yeah. These still need to change. Interpreter. And then we gotta change this. Boom, boom, boom. Oops, dot get environment paren dot set color. Okay, nice. So I think everything should compile now. Let's double check that. Good. And now we're ready to actually do this part. So we need to introduce a method on interpreter called evaluate. Now let's see. I think we want that kind of separate from this stuff. And this needs to be async probably. Well, okay, maybe it doesn't. Yeah, let's try it not async, and then I suspect we'll eventually make it async. Evaluate, and this will be block, which is of type element. And now we need something here. So I think we have to introduce the idea of like a return value in our little like language of our app. So let's see, where's a good place to define this? We might be able to put up here. And we could, let's see. It is a value. I guess we could name spaces like program value. And then this could be a number. but it could also be a color, right? And like color doesn't exist yet. But it'll have to be made up of like component parts. So this is going to end up being like an object with HSB inside. Cool. For now, I guess it's just number. So let's leave it at that, and we'll add to it as we go. Now, you know what else we could do? I'm gonna move the interpreter over here. Notice how like time expression could just be null. Maybe we should write this so that we could just evaluate null and then we get null. We have to decide like what do we do if this is just totally blank? Now maybe this should actually be an error. I mean, like, this is not really a valid program. Wait for void seconds. Wait for null seconds. So this should probably raise an error. Throw an error. I'm switching between languages today. Let's make it throw an error. So I think that means time expression needs to be an element. Therefore, if time expression doesn't exist, this is bad. And we don't really have stuff in place for like handling this if this gets thrown. That can come later as well. So let's you don't need an exclamation mark. Let's just do this for now. So now we know time expression has to be an element if it gets down to this point, and we can evaluate it. So when we evaluate a block, which we know is an element, this will return a program value. Yeah. Oh, I know why this has to be async now. And the reason is because we are going to be calling handlers like this one. Yeah, which have to be async because they might be statements that are like spend 1.5 seconds transitioning. Okay, yeah, that makes sense. So let's see, we've got to look up the handler. We've already got some like logic for that. You'll notice it's like up here, tick. So we can grab this and then grab this. So now let's see, we have a handler. We should be able to say handler.evaluate block with this interpreter. And we want to return this thing. But according to our iBlock handler, evaluate is a promise that contains void. And so this can now become it can become this program value. We're exporting from there, put in there, sweet. So this works. Now we just broke everything again. So we do need to introduce the concept of void. So, like null, Are we going to treat null and void as distinct types? Are we going to do null and undefined and void? Have we just created a language with 3 nulls? We'll probably go to prison for that. Let's see. How do we want to express that? I think we could just say that void is the same as null. So essentially right here we would say return null. Like if we're waiting, the result of this is null. On the other hand, like I think when we look at this is not even a valid program with a number missing from here or an expression missing from here. Same with like this set color to undefined, like this should be impossible, this should be impossible. And so I think we need a way to like validate our program, which we can introduce when we get a little more of this in place. But I think what that means is null might not actually exist in our language. In which case, we can just introduce this like void, basically. I think so. I'm actually gonna do. I'm gonna do a discriminated union right here. So now we've got type void. So let's see. We need to say that we need evaluate, or we need evaluate to return that. And I think we can say return type void. So we know that that's a program value. And now we should be able to say I think we're not quite ready to say times seconds, but we can say like result equals that. And then we have to do one more type check. So we have to say if result.type is not equal to number, then this is also an error. Time is not a number. Let's save that first. Oh, sure enough, we have to await evaluating this. That totally makes sense. So we do that. If it's not a number, that's a problem. We throw, and time seconds should be result dot value. Boom. Okay, that looks good. But we've broken everything because we just changed that. Now let's see, what am I... Oh, do I have to do something like this? I don't think I should have to... Okay, it did accept that. We can probably... the type inference is failing here, so I think we could do program value. Yeah, and that's a promise of type program value. And it likes that. I think we should write it this way. I like that. Okay, now to change everything. This is going to be a promise of program value. I'm going to change it over here. Type void. This return returns void now. Start block. Returns that. Okay, so I think we've done our change there. This should compile. Looks like we missed one. Light on block? Oh yeah. Okay. Here we go. Try running that again. Oh, it said found 2 errors. Like, oh yeah. One caused the other. So, all right, our code compiles, and now let's see. I would like to see. I would like to see this in my console. Rerun it again. Here we go. Click run. Okay. No handler defined for block type math number. It's true. Let's define that. We'll call it a number block. Let's copy some boilerplate. Actually, it's gonna be sort of like this one. And let's see, we're gonna call this number block, math number. And let's see, we're gonna parse float from, is it number? Let's, math number, it's num, right there. That should be of type number. And then we say return number value is value. Yeah. Now let's see, we're not defining that block yet, so we need to add that here. There we go. And I don't have this in any particular order. It's like kind of alphabetical. Not really. I think eventually this will kind of shape into like categories. So I'm not gonna stress about it for now. Okay, let's run this again. Here we go. Hit run. Oh, that felt like 3.5 seconds to me. Look at that. Time in seconds, 3.5. Oh, we did it. We did it, we did it. Cool. Nice. Well, let's clean this up a little bit and commit it. I think we should be excited about this. You'll notice there's a few uncommitted changes from before. Let's see if we can split that into their own commit. This stuff. result feels a little weird. Time result, maybe? Yeah, so it's like evaluate the block, force it into the type that we need, pause for that long, return. I like how that reads. Okay. Let's do some of this. So we're evaluating all the things. Yep. So now we're to our front-end code. Oh, we for sure want to add this guy. Let's just see really quick what else is here. Some of this we kind of need because like that weight block is right here, yeah. So let's add all this. We can keep Zealous in its own commit. So we'll say evaluate expressions, implement weight block. Switch to Zealous render. Sweet. That's up there. Just a reminder, this is all available on GitHub. White blocks. Just blanking for a minute there. Yeah, so here it is. I'm gonna chuck this in the chat. So yeah, feel free to pull this down, follow along. You should be able to run it on your network as well, as long as you set the .env file that it's expecting. Yeah, we're looking good. And we gotta check this off. I like that. Let's do this now, because this is where things start to get really cool. Then it starts to really feel dynamic. So, and let's go off-roading again. I think we can just define this in code without really reading it. And I'm gonna call this like math random. Maybe math random between actually. And we'll say random number between, and then this will be min, and it is a number. Min and max. Yeah, nice. Now, and let's see, this needs to have an output. Are we doing that on set output? Here we go. We'll also probably want that. And we do not want this. The other thing that I'm thinking about is the color should be, yeah, I think this is what those are set to. And we can eventually pick like a cool color palette as well. Oh yeah, the other thing we have to do is add it to our toolbox. There we go. There we go. So now we should be able to start to do this. Okay, so this doesn't plug in right now because we haven't defined its output type. Wait, I thought we did. I thought we already did that. Oh, that's wrong. That's just wrong. Okay. There we go. And now we should be able to say wait for this many seconds. Yeah, okay. Sweet. So let's implement it. And we'll do like, let's see, where's my number literal? There is a way to default this to a thing, or like basically have this appear with number literals inside of them. So I think we should switch to that when we get the chance. So let's say like between 1 and 5, something like that. And we'll turn the light on, wait, turn the light off. Run. Boom, it's gonna crash. Yeah, because this doesn't exist yet. So let's build that handler. So this is called random, what do we call it? Random between. And we're gonna do some of the same stuff as here, so let's use that as our starting point. Math random between. Okay. Let's I'm just thinking about it. Oh, I didn't actually build that. Okay, we're gonna keep the light on until we get this fixed. I was like, that's just so, it's weird, but it serves us right. We tried to run a program we knew would not actually work. So we're gonna do min expression. And this is a random between block is missing min expression. And then we need to do a max expression. And here's the thing, like, so min is not a number. So now this is min seconds equals min result dot value. Okay. Now we have to do the whole thing over again with the max. And I'm not liking the amount of boilerplate that's here. Like this is getting hard to read, and it's like very copy paste. So I'm wondering if we can refactor some of this into a block utils where we say like get a value, assert that it is real, evaluate its result, make sure its type is what you expect. You know, basically like do all of this in a single line. We can experiment with like where we extract that. Yeah. Okay. So let's see, we have our min in seconds and our max in seconds. So now we need to actually choose like random seconds is going to be some expression. And for now it's 1.5. So the idea is we'll return type number, value, random seconds. And this is the one line where we actually like do the thing. So I think we could say math.random. So that's a number between 0 and 1. We need to scale it and we need to offset it. Plus min seconds. And let's... This is going to be math.random times max seconds minus min seconds. Right, so we got max of 5, min of 1. So that's, you know, a range of 4. 5 minus 1 is 4. Math.random times that 4, and then you shift the entire range of outputs by min seconds. Yeah, so that looks right. Cool. So I think that's it. I think that is our expression. Grab this, and we will define it. Random between, you can see me being lazy. Auto-completing. Okay, so that's there. I've got my dope trailing comma as well. And now, here we go. And we're in a broken state, so let's refresh the UI. Turn the light on, turn the light off. Wait for random number between 1 and 5. You know what? The other thing that I would very much like to do random. Oh, hey, guess what? I'm saying like min seconds and max seconds. There's nothing in here about seconds. Like this doesn't have anything to do with time. So let's actually just change this to value. And really, I don't know if we're... oh, we might extract that. We might refactor that part. Let's just... I'm gonna keep these variables for now. Random number chosen. And then this should just be like random value. Yeah. All right. We've got everything running. We run. It's waiting. That felt pretty fast, but it did complete. 1. Let's run it again. So it felt... it chose 1 again. Do we have a... Huh, is something going on here? Let's add some more logs so we can understand. Yeah, that'll help. Whoops. npm start. Run that. Oh, hey. Okay, so it thinks the max is 1, which is wrong. That's why. This again. this. Hey, look, that waited for a while longer. Ah! Minimum 1, max of 5. It shows this big floating point value. And it did it. Let's run it again. 1.7. There we go. Let's do it one more time. 3.4. Awesome. Okay, this is working. Oops. Yeah, this is awesome. This is starting to feel like a program. It's not too much yet, right? But like now that we're like 3 levels deep and we're able to like, this knows nothing about these numbers inside of here. It just knows it's evaluating this, but then this in turn like evaluates these. So that's awesome. Like this is turning into a thing. So let's check this off, and I'm gonna commit this, and then let's we're gonna say refactor logic for getting sub expressions. Okay, so we define a block, we add it to the toolbox, define it on the front end, and then we define it on the back end. There we go. Push that up. So let's figure out how we want to refactor this. I think I want to do something like maybe something like that. And then I think that can be still of type program value. Yeah, and then inside of that, we can run this. And if it doesn't exist, we throw that. We evaluate. Oh, so we have to pass in the interpreter. I'm going to put it on the end here. Block min, it's a number. Here's the interpreter. Yeah, I think that should work. Nice. Okay, so let's put that in block utils. This does feel a little weird that we're passing in the interpreter, so maybe we want to tweak that. Let's see, what do we have in here so far? This is all just like working on XML stuff, so it does feel a little out of place. Okay, well, so what if we do like interpreter dot get typed value? And it's like, give it a block. Man, it should be a number. I think I like that. Yeah. So let's see, here's our interpreter. And we're gonna say, oh, by the way, this is a wait. Async, and let's move it kind of down below. Get typed. This should This should probably be like evaluate typed value. Yeah, I think that's a better name because and I'm even gonna switch this around. And so this is going to be a block. Value name is a type string. And then type name. For now it's a string. I would like to lock this down further because really it should only be this or this. So I guess we could just like keep them in sync with each other. Program type. That's a type, program type. We'll just call it type. And that is going to return a promise of program value. Yes. So now I'm going to grab this. Whoops. Min.value. Ooh, this doesn't always exist. Okay, I have. Oh, I wonder if I have to do like program value number. Well, let's. Okay, let's. We're getting carried away here. Oh no, I can't even. Yeah, see, we're fighting a little bit. Can I do that? We're fighting against our type definitions here because, as far as this code is concerned, min is any kind of value. So let's, for now. I'm going to say if min.type is not equal to number, throw new error, and this is unreachable. Fix me, fix types, so this is not needed. Okay. So yeah, coming back over to here, add our import. And then we're just making all this generic now, right? So I'm gonna call it sub expression. And say block is missing expression for value name. Put these in magic ticks. Equals this dot evaluate. And then we should say sub expression result is not a let's do that. Expected type, result.type. But if we get past all of this, then we can return result. Yeah. Okay. And now let's see if we can... What's the right way to write that? How about we... I'm gonna copy that over here. Okay. Put a hyphen here. So let's just make sure that everything still executes. Run. Okay. Yeah, good, good, good. Let's see. So we need to make this more expressive somehow. So we could do something like value is a type number. But then we could say let's make another one of these void. And then we could say export type program value is equal to program value number, or program value void. And we remove that. And so now we can point to each of them independently. Spill a little bit of water when I'm deep in thought. So, I mean, now maybe I could do something like program value number. At which point I could probably just remove that. And see, like, I would love to be able to remove this because this should imply it. So I guess if I want to do that, I need a type guard for all those types. Okay, I think yeah, I think we want to go down that road. That seems like a good road. So, and let's see, I'm gonna forget how this is written, but we introduce a type T. That is gonna return a promise of type T. And I think we need to say, oh. I'm not sure how to lock that down just yet, but I need to somehow say that that is a type. Like, it's only in that set of types. Oh gosh, I'm not super confident in how to write this. Yeah, maybe what we really want to do, because I mean, this is doing two things. Like, maybe what we actually want to do so we can like return result here, and then this is where we need to like assert that. So maybe we say assert result type. And let's just write this here real quick. And this is a type program value. And then this should be type, which is a type program type. And it returns void. Oh, but you know what? It's this is actually a TypeScript predicate. We've basically written a type guard. So then we could say result is, that doesn't make sense. We can't say that. But maybe what we could do is like program value of type program type. Or of type. Is that how you do that? Now I think that's a... Oh man. This is crazy town. Types are hard sometimes. We could... You do that? Oh, this should be... And then result.type is now equal to number. And we expected number, but we got something else. If we make it past this, then it's true. What are we doing wrong here? Type predicate's type must be assignable to its parameters type. Program value number is not assignable to type program value. Well, right, I mean, like, it's not assignable under every condition, but we've just proved that it is. Huh. Gross. I feel like I'm failing at my TypeScript today, you guys. I'm gonna go and like read up on this and learn what it should be, and I'll check in another commit some other time that actually like cleans this up in an elegant way. For now, what we're gonna do is we can do something like this. And I think that will actually compile. Yeah. Why is that unknown? Oh, I've got to save this. Okay, so we moved this out. Get rid of this generic. Now it's just a value. And I renamed it. Yep. But come on, by the time we hit this line, we should know that min. Oh, we could do something like, we could call it like cast number value. And then really we could even like collapse this down a little bit. Yeah, and then like if this goes wrong, this will actually throw. Okay, I feel pretty good about that. Yeah. And then we could have another one for void later. I think that looks pretty good. Wow. Thank you all for bearing with me. We got to an answer in the end. And now I think we need to put this somewhere, and we probably should put it in the same place as this. So I think we should make a program value. And let's see, we'll keep that there. That in there. Oh, let's see, we probably want this like up here. From program value. Okay. Import all this stuff from program value. Oh, we only need that stuff. Okay. We no longer need that. And then we can grab this and move it into here. So now we've got like our type guard type stuff in the same place as the type definitions, which I like. Save that. Oh, now this is unused, which is cool. Yeah. Ah, and we've broken everything because program value doesn't exist in interpreter anymore. So that's good. Ah, I kind of wish it did. I think it probably shouldn't though. Copy this a bit. Oh, hey, that's the file we're already in. I don't know what that's doing now. Let's delete that. Okay. Have we changed everything? Yeah. Which means this should execute now. Good, good. Hit run. And nice. I found the min and max. It did the thing. Things are looking great. Okay, and I like how tidy that looks now. And I'm going to remove these because we feel good about them now. This is growing on me. maybe this actually should just return the value. I think that's a good API. You know, like yeah. Cast number value, is that named how it should be? Cast number value, so you're casting it. Maybe it should be like extract number value or get number value. But I mean, like there is an implicit cast there. Yeah, maybe cast number value is the right one. The other thing that we should do though is we should put it in here. So let's see, this can be time. And then this is going to be time seconds. And we can delete all of this. Oh, this should be time seconds. Wait, how did we get min seconds in there? I think I have min seconds somewhere in my code. And I will find it. Okay, I don't think we do. I feel good. Feel better. Remove that. We can pass that in. Sweet. Yeah. And we're going to be hitting both of these. So when we execute this, if everything runs, we know that both of our changes worked. Okay. Cool. It did it. I think that's a commit. Made a bunch of changes. Git add that. And we're gonna say improve types for program value. Refactor logic to, well, I guess it's not even like improve the types. Maybe say like clean up interface for getting, for evaluating value results, sub-expression results. Boom. Okay, where were we? Yeah, we got just that one left. Okay, yeah. I think we can knock this out. It's now that we've got this other stuff kind of cleaned up. I think it'll just take another like 10 minutes. Set color. Wait, do we already have that one? Oh. Because now we have to say set color to color from components. Yeah. There are a few things going on here. Let's see if we can knock it out. I don't want this session to go super long. Maybe we should actually call it here. I think we'll leave this as a exercise to the viewer. You'll see me add this commit later. But tune in next time. The thing that we're going to do next time is control flow. So think like if, else, while loops, and just like loop forever type stuff. So far, like this type of program, like if you want your program to do more stuff, you just gotta like chain it taller and taller and taller. But as soon as we add looping, things are gonna get way cooler, like way more dynamic. So get excited about that. That should be either next week or the week after. Double check. But yeah, thanks for tuning in. Or if you're watching this in the future, thank you. And yeah, have a good one. Stay creative.